Let's go ahead with the sixth group of properties. Here we have the addition of two inverse trigonometric tan functions, that is tan inverse of x plus tan inverse of y is equal to tan inverse of x plus y upon 1 minus xy, where xy is less than 1, or it is equal to pi plus tan inverse of x plus y upon 1 minus xy if xy is greater than 1 and x and y are both positive. And lastly, it would be equal to minus pi plus tan inverse of x plus y upon 1 minus xy if xy is greater than 1 but now x and y themselves are both negative numbers. Okay. So that means depending on which criteria are satisfied, we have three possible expressions of the left hand side. Okay. Now let us prove the first one, that is when we have xy less than 1. Now if you look at this closely, we want the product of x and y to be less than 1. Now this can be achieved in many ways, that is it might be possible that both x and y are positive and their product is less than 1, or it may also happen that both x and y are negative yet their product is less than 1, that is also possible, or x is positive and y negative, so that their product will be negative, which has to be less than of course 1, or the other way around, that is x is negative and y is positive. So for all of these four sub cases, the first property always applies, okay, because we are mentioning only xy is less than 1. So now let us prove this particular property, but we will prove it only for one of the sub cases. For the remaining sub cases, the method of proving is exactly same. Okay. So let us prove it for the first sub case, that is x and y both are positive and their product is less than 1. So go ahead to the next slide to prove this. To prove that tan inverse of x plus tan inverse of y is equal to tan inverse of x plus y upon 1 minus xy, where xy is less than 1, and now we are considering the sub case of x is greater than 0 and y is greater than 0. You see, we want strictly positive numbers x and y. Okay. Alright, so now we begin with looking at left hand side. If you look at left hand side, the first term is tan inverse of x and second is tan inverse of y, which indicates some angles, isn't it? So let us call those angles as say alpha and beta. Okay, so let us say that let tan inverse of x be called as alpha and tan inverse of y be called as beta. So that means we can write x to be equal to tan alpha and we can write y to be equal to tan beta. Now note that whenever we are saying tan inverse of x is angle alpha, that means alpha lies in the principal value branch of the tan inverse function, and similarly beta also lies in principal value branch of tan inverse. So that means alpha lies between 0 and pi by 2 and beta also lies between 0 and pi by 2. Okay, because we want x and y to be strictly positive, we don't even want to have them as 0. Okay, now let us club them. So the left hand side becomes alpha plus beta. If we add both the inequalities, we will get alpha plus beta to lie between pi by 2 plus pi by 2. Okay, so therefore we have alpha plus beta to lie between 0 and pi. So this is a very important finding. That means we can say that the sum of alpha and beta lies between 0 to pi. That means the angle alpha and beta lies either in the first quadrant or in the second quadrant. So we have to keep this in mind. Let's call it this as maybe fact 1. Okay, now if you look at the left hand side, it is basically alpha plus beta. Okay, and here we have tan inverse. Okay, so let us consider the identity tan of alpha plus beta. We know that from basic trigonometry it is equal to tan alpha plus tan beta whole divided by 1 minus tan alpha tan beta. See, this is an identity, so that is true no matter what are the values of alpha and beta. So therefore we can say that tan of alpha plus beta is equal to, tan alpha is nothing but x and tan beta is nothing but y. So we write it as x plus y upon 1 minus xy. Alright, now we can shift the tan to the right hand side and write it as tan inverse of x plus y upon 1 minus xy. This is what we want to write, but we can shift that tan to the right hand side only when we have proven that the angle alpha plus beta lies in the principal value branch of the tan inverse, that is between minus pi by 2 to pi by 2. Correct. Now for that, let us look at the expression on the right hand side that we have obtained just now. We see that x and y are both positive numbers because that is the subcase that we had started with. So that means the numerator is definitely a positive number. Then we have also assumed, basically that's the case given, that is xy is less than 1. So that means clearly 1 minus xy is also a positive quantity. Correct? That means overall the right hand side is a positive quantity strictly. So therefore if tan of alpha plus beta is a positive number, that means we can say that alpha plus beta must lie in the first quadrant, that is it must be lying between 0 to pi by 2. Correct? So now therefore let us club the fact, that is since alpha plus beta lies between 0 to pi by 2, that means now the second quadrant has been ruled out and what we have shown is it lies in the first quadrant, and first quadrant, that is 0 to pi by 2, definitely belongs to the principal value branch of tan inverse, that is nothing but pi by 2 to pi by 2. Now therefore we are allowed to transfer the tan to the right hand side and say that alpha plus beta can be written as tan inverse of x plus y upon 1 minus xy, and lastly we just replace alpha and beta with whatever we had assumed. So therefore finally we get tan inverse of x, that is alpha, and tan inverse of y, that is beta, is equal to tan inverse of x plus y upon 1 minus xy, which is the required property. Okay. Now similar to these properties, there is next a group of properties, the subgroup, that is where we have the subtraction, that is tan inverse of x minus tan inverse of y, that is instead of plus now there is minus. If you see here also you have a very similar pattern, that is the basic term is same in all the three. There is just additional term of pi or minus pi based on the given values of x and y. The first property or the first case applies when xy is greater than minus 1. Now if xy is less than minus 1, so there is a small typo here, if xy is less than minus 1, then there are two cases, either x is positive and y is negative, or x is negative and y positive. So accordingly you will have two possibilities. Okay, so these properties can also be proven on the similar lines as before. Let's go ahead and solve one sum. Here we have to prove that tan inverse of 1 by 2 plus tan inverse of 1 by 3 is equal to pi by 4. Now looking at left hand side, we immediately recognize that it is of the form tan inverse of x plus tan inverse of y. Okay. So here if you consider 1 by 2 as x and 1 by 3 as y, you see that to apply the property tan inverse of x plus tan inverse of y, see this will be equal to tan inverse of x plus y upon 1 minus xy only when the product xy is less than 1. Okay, so we have to first confirm whether this condition is satisfied. So if you see 1 by 2 into 1 by 3, that is 1 by 6, which is clearly less than 1. So yes, we can use this particular property. Okay, so let us go ahead and use that property. So we say that LHS equal to tan inverse of x plus y upon 1 minus x into y. Right? We use the same pattern, and instead of x and y we write 1 by 2 and 1 by 3, and we have to now simplify this. Now here a tip is that, like, don't cancel any denominator, that is, keep the same two denominators in the numerator as well as denominator of the entire function. So in the numerator 1 by 2 plus 1 by 3 is 5 by 6. In the denominator you have 1 minus 1 by 6. So we have tan inverse of 5 by 6 upon 5 by 6, which turns out to be tan inverse of 1, and clearly tan inverse of 1 is 5 by 4, which is the right hand side. That's the proof.